Really great to see you, everyone. So I'm Steve, founder CEO of Lightwheel. So my topic is to accelerate embodied AI with simulation. So a little bit quick introduction of myself. So I was previous head of simulation from Cruise, from NVIDIA, from autonomous, and also head of autonomous driving simulation from NVIDIA. And basically, a very quick question for everyone: is simulation a game for robotics or not? So a lot of people, they like to refer to simulation, like a robotic simulation, a game for robotics. So I would say it is the answer is yes and also no. Yes, in that so basically a lot of the technology, the concepts and other things can be borrowed into building, the most physically accurate simulation for robotics from games. But also on the other side, the purpose is totally different. The games is mainly for people, for human being to enjoy, to play in the virtual world. But actually the simulation is to train the robotics, to test the robotics, and also to be able to deploy it from sim to real into the real world. So the connection with the real world actually is very important for simulation. So with that in mind, I want to quickly introduce my company. So Lightwheel right now is already the global leader in synthetic data solutions for physical AI. And on the right-hand side, you can see, we serve a lot of really great clients in, embodied AI in robotics. That includes NVIDIA, DeMind, and also research institutions like Stanford, MIT, the top basically embodied AI robotics companies like Figure, Genesis, HiBot, Galbot, and also a lot of very large corporations like Alibaba, ByteDance, Bosch, Toyota, and more. And on the right-hand side is basically the set of products we carry. So I would say we carry the first product is the SimReady assets for the very realistic, not only visually accurate, but also physically accurate simulation for robotics. So this is, in my opinion, the most critical thing needed in order to have high quality simulation for robotics for now. And also the second one is from those SimReady assets, since from the best simulator we can leverage, and also from the teleoperation solutions that we carry, we can generate very large, diverse, and high quality synthetic data sets to enable the robotics foundation models training. And after this product, what we can provide is basically the simulation platform, the framework that we can enable our customers to not only leverage imitation learning to train their vision language action model, but also to leverage reinforcement learning fine-tuning to fine-tune the vision language action model to have I would say the best for performance to reach the DeepSeek moment for the VLAs. And why we are so interested and why we jump into synthetic data for physical AI industry? I would say the answer is I really think the physical AI data demand will be 1,000 times bigger than the large language models. So I'm only doing for a few very quick comparisons there. But basically, a very intuitive way to think about it is basically for large language model, for the pre-training data set, it is all given from the internet, right? But basically, for the but basically for the physical AI, the pre-training data set needed is much larger. In that, it not only would need the internet data, but also it would need the video, the 3D data, in order, for example, the data from self-driving, the data from robotics, in order to enable the pre-training. And also on the other side, from the post-training perspective, So basically for the large language model, so the major customized data demand is on the post-training perspective, but also on I would say on the physical AI side, the post-training side opportunity is much larger. You can see there is a lot of the human demonstrations, the teleoperations, the human-centric data, the data collection with a different type of motion capture capabilities, things like that. So in all, I would say, the physical AI opportunity of data side is much larger. And in order to solve this data shortage problem, we need to really rely on the data pyramid concept. So for the data pyramid concept, it is not only the real world data that we can leverage, but also the synthetic data and also the web-based data, right? And I would say in this part, so in this pyramid, the most critical data that is in need, in my opinion, is the synthetic data, right? Because basically we can leverage real data and also synthetic data technologies to augment the real data into the synthetic data part, but also we can leverage a lot of the combination of the real human demonstrations and also the simulation to get a lot of synthetic data. And I would say for here, the most critical thing needed is the synthetic data technology. And with this technology, I really see that, we can bring a much larger and high quality data pyramid standardized products for a lot of robotics pre-training and also post-training purposes. So with this in mind, I will quickly show you a demo. So you can see in this demo, so this is not only visually accurate, but also physically accurate fridge, right? So I would say, so I wrote the topic that what we need is not only high fidelity, but most importantly, physically accurate simulation. And why I'm saying that part, right? So I want to give a very interesting, I would say, analogy here. So my kid is 1.5 years old, and I would say that if I provide him like a graph of a bicycle, but basically if I draw a graph of bicycle, he can still recognize it. Like my graph wouldn't be a high fidelity graph. It wouldn't provide the best visual. But with his, like large model, he can totally understand this is a bicycle. But at the same time, it's very difficult for him to ride, to learn to ride a bicycle. I mean, he's only about half year old. And the most critical part is for him to interact with the real physics. So in the simulation, I would say the most in simulation, in robotics simulation, the most critical thing that we need to provide is to train the robotics to understand the real physics, right? And in this demo, basically you can see this fridge. It has even the accurate magnetic force from the real world, and also the multi-friction. So this is what really differentiates us versus the others in, I would say, the robotics simulation. Cool. So today my agenda is I will quickly showcase to you, how we really think about the high quality SimReady assets and how it can enable the accurate physics of simulation. And with all those accurate high quality SimReady assets, how we are gonna generate the data collection, the synthetic data set that is really going to power up the vision language action models pre-train and also post-train. And with this data set, and also I will give you the real best practice of how we enable, for example, the GR00T N1 training and also post-train from the level synthetic data. cool. So I will go over them one by one. So this is a very interesting, I would say, industry use case of cables, right? And you can see that basically to simulate the deformables actually is a very difficult task. But on our side, we can actually simulate the cable effect pretty well. And also being able to, for example, cut the different type of deformable objects, for example, cucumber, sausages, things like that. And also this is very, very important in order to simulate accurate physics, right? And enable, the robotic stack's hand to leverage the different type of tools, right? To interact with very realistic, diverse scenes. And this is one of my favorite in that we will call this the pickable strawberries. The strawberry itself is deformable, and also the stem, like basically you can you can pull the strawberry off the stem. This is very difficult to simulate, but I would say the most critical thing here is not only you can pick up the strawberry from the stem, but also all this SimReady asset scene is enabled not only for data collection, but also for reinforcement learning in SLab, right? And we are actually enabling our customers, right, to train reinforcement learning policies real in their real manipulation-based robotics in farming. And also this is basically folding cloth, right, through, I would say, the Newton simulator from NVIDIA. Again, this scene is 100% reinforcement learning enabled, right? Meaning that basically we can directly train our policies in this. Cool. This is also another, I would say, industrial scene, right? Basically, how to squeeze, for example, this cable into this car door, right, and pull it out from the other side, right? So this car door is basically rigid body, but basically the cable is deformable, right? And how to provide the very accurate simulation, and also how to enable not only data collection through real human demonstrations in this, but also reinforcement learning. And that's the part that I would say our simulation specializes at. Yeah, definitely it looks very real, and I would say from visual perspective, this is awesome, right? But also I want to mention that it's not only the visual, it's more about the physics. Cool. And you can see where I'm going. Basically, the simulation, the robotic simulation is really taking into effect into many different type of industries. So the more I'm working with our customers, the more I see that our customers was our customers was very, very, in my opinion, centralized into the robotics foundation model makers, like the big orgs, research labs, right? Building the robotics foundation model. But now I really see there is a trend of our customers diving into each different type of industries, right? For example, the manufacturing industry, the farming industry, as I just mentioned, and for this one is basically the bio labs, the biology labs, the chemistry labs, the different type of labs, right? And previously, all those labs, they want to leverage human beings to do all the research. And right now, they want to leverage a lot of automation. And in order to train the automation-based robots in labs, they need very accurate simulation. So this is what we can provide. We're actually providing full suite of, for example, chemistry, bio lab, equipments all in simulation, not only data collection enabled, but also reinforcement learning enabled, right? To train the different type of robots there. And like it's very interesting for some of our customers. They want to leverage humanoid to do this. Some of our customers they want to leverage robotics arms there. It's very interesting to see how fast this whole robotics industry is growing right now. And also this is very interesting. So this is in the medical industry, right? And this is basically to provide the liver, the organs, to enable the training of the robots to assist certain surgeries. So for this one specifically, it's a liver surgery, but also we are working on, for example, the spine surgery, spine surgeons, and other medical device companies there. And the use cases are also very interesting, right? It starts with, the different type of surgeons want to having certain assistance in surgeries. Then into that, they not only want to train the robots, but also train the young surgeons to do very accurate simulated surgeries, right, in simulation. So you can see that for this liver, it is deformable. So it's very difficult to make this very small cut. And there's still a lot of things to go for, in my opinion, the medical space simulation. We are just getting the very early step of this, but I'm very excited about all the potential is in the medical space, in that we are getting a lot of demand in this. So just to summarize on our, I would say, standards for the SimReady assets there, we really see that, but definitely I would say starting point is visually accurate, right? The best visual quality. But after that, what I think really, really matters is the physical accuracy, the physical readiness part, right? And after that, how do you really qualify, the physical accuracy? So I usually use an example in that if you decorate a new house, right? If you buy a newly constructed, decorated apartment or house, right? Usually it will come with certain issues, right? Only after you live in the house for probably say 1 month, right? You will start to see a lot of issues there. You start to fix a lot of issues there. Then it will be like very fully in use. So same way for, I would say, SimReady assets and scenes, in that a lot of the issues there, you wouldn't know if you are not using it, right? And ultimately, what we are building is a simulated home for robots, right? So the best way for us to qualify it is to let robots to live in it, right? So we would let the human to tally up in robots, in simulation, right? To qualify all the SimReady assets scenes to interact with them, right? Just to make sure, the quality, the usability, everything is well. And after that, I would say is the most critical part, which is the reinforcement learning readiness part, right? In that this SimReady asset scene, it not only needs to enable, the real-time data collection, but most importantly, on one GPU, span of potentially thousands, if not tens of thousands of parallelizable environments, right? All training reinforcement learning, but also having very accurate physics in it. So this is basically showcasing that how we are doing the benchmarking between the simulated asset and also the real asset, right? So on the right-hand side, you can see the curve. One curve is the first collector collected in the real world, right, for this store. And the other curve is the simulated first collector collecting in sim for this microwave, right? So what we are trying to say here is we have the best practice, right, to really have the real data collection of the physics, right, from the real world, and put it into sim, not only doing the collection, but also doing the benchmarking testing, right? To just make sure, the physics are accurate, which we think are very important here. Cool. So after we get all this really great, very large, diverse, high quality set of SimReady assets and scenes, what will we do? We actually do the data collection from them, which I think is the most cool part. So you can see in this demo that our teleoperator is leveraging the different type of data collection hardware equipments, right? Starts with for the space mouse, the MetaQuest, right? But also with the different type of escalator. For example, for here you can see. So this is a gyro solution. So basically gyro plus the joystick with the force feedback, right? So it can collect very accurate physics to enable the human teleoperator to embody into different type of robots, right? The robotics arms with movable ways, the one with Dex hand, and also humanoids, right, to collect different type of data. And this teleoperated data is very important, and I would say it is much more efficient, but also a lot of time more high quality than even the real data collection from the real robots. Why? Because so I'm not sure if you have seen a lot of the real data collection, real teleoperation from the real robots. Usually the scene that you are collecting is very limited, right? Usually it's tabletop or very fixed, demo-based home, IKEA setup home, right? So it's very limited set of scenes with very limited diversity, right? The other thing there is they wouldn't use, for example, if you want to grab a banana, they wouldn't use a real banana. They would use a plastic fake banana to do this type of data collection, right? And also this is just one type of banana to grab it, say 1,000 times, right? So basically, if you train the model with this type of data, it's very likely the model would overfit into this one type of plastic banana that you use, right? But in simulation, because of the high quality SimReady eyesight scenes, the very diverse scenes we can set up, the randomization of the eyesights that we can choose, we can provide much more diversity. On the other side, we are still capturing the real human demonstrations from it, right? And combining the two, actually, we can get really great results from a training perspective. And this, what I'm demonstrating you is the world's largest synthetic data factory. So in this room, those people, they are not engineers. They are teleoperators. They are using a different type of data collection equipments, right? For here, Drilo, but also, for example, for the space mouse, Vision Pro, MetaQuest, and others, just to embody into simulated robots and do the data collection. We are creating a lot of data every day just for robotics foundation model training, but also fine-tuning purposes. Oh, now with this data, what do we do, right? So I want to provide you some of the real use cases, right? The best practices. So GR00T 1.5 is, I would say, the NVIDIA's humanoid foundation model, open sourced, and it is one of the best foundation model in the world. And basically, Lightwheel really enable the foundation model training through our teleoperation data collection. but also not only enable the foundation model training, but also enable the fine-tuning of the foundation model after training, right? To helping it to be deployed through sim-to-real into real factories. So you can see that for here, we leverage the group N1.5 foundation model. And on the left-hand side, we created the synthetic factory, right, through the real to sim from a real factory. But we have introduced a lot of different type of randomization in it, right? And also we let our human teleoperator to collect the teleoperated trajectories in simulation. Basically, the pick and place tasks. And on the right-hand side, we leverage this type of data that we collect in simulation to fine-tune, to even further fine-tune the GR00T N1.5 model. And also through the sim-to-real, we deploy it in real car manufacturing factory. Actually, this is one of the world's largest car manufacturing factory to handle the real task. And then basically for you, I also want to introduce something that you can quickly give it a try, right? So for Lightwheel, we also work on a lot of very fun open source projects here. So for here, I want to introduce the ASIC. So the ASIC is basically a open source ASIC sim framework that basically has the robot in it and can allow you to do the teleoperation in simulation through a robot, collect the data, and also to fine-tune the vision language action model to do the imitation learning, and then to do the sim-to-real and deploy it into the real robot. So I'm not gonna go over the details here, but I would say that for here, like we have provided all the tutorials. You can go to our LinkedIn to take a look. And this project, the ASIC, is fully open source on GitHub that you can give it a try. And with this, the ASIC, what you can do is you can, so for example, for this example of pick up the orange, place it into this plate, you can collect, the real the teleoperation demos, right, in simulation. And then you can leverage the mimicgen to augment these trajectories, right, in order to get 20 times more data from your original demonstrated data in simulation. And with this data set up, with this data collected, you can fine-tune the robot and make sure it's sim-to-real in the real world, fulfilling this task. And the very, very cool part is, we also introduced a lot of, very interesting SimReady asset scenes, all open source, into this project, just to make it more fun for you to play with. And with that, we actually hosted a lot of events there, and we want to challenge, like our audience base, our user base, right? So we pick, kids. And in this session, we actually taught around 20 kids to learn robots, learn robots from our the ASIC open source project, right? And also to collect their teleoperation clips to augment it, to fine-tune the vision language action model deployed into the real robot with a success rate of more than 50% within 2 hours, right? So I would say if kids can do it, then I would really think that everyone can do it. So that's, in my opinion, the power of simulation, right? It can really help us to democratize robotics to everyone. Yeah. So with that in mind, I want to close my today's session to say that I would say we are very excited of simulation and what simulation can accelerate robotics, can accelerate embodied AI. And we really see that still we are just getting started with this robotics industry, right? And we really want to work with you, want to work with everyone to make simulation successful for embodied AI together. And you can just scan our QR code to follow our LinkedIn. And again, really appreciate the invitation from Voxel 51.